The first derivation which I will be deriving in this video tutorial will be the whole life level immediate annuity notation AX. This video will be as straightforward as possible for the viewer to understand. We must start by defining what this annuity is. A whole life level immediate annuity issued to the policyholder is a level annuity, which is a series of payments, payable at the end of the year, depending upon the policyholder's survival. It is best if we first draw a timeline for better understanding. This timeline is the key to deriving AX. We can clearly see that the timeline will start by the person acquiring the whole life level immediate annuity. Eventually, after a year passes, we will arrive to the X+1 stage. Since the benefit is paid at the end of the year, we have no terms occurring at point X. Here, TPX will be used, since for the payment to be made, the policyholder must survive from the inception of the policy up to the point of payment, which occurs each year. In this annuity, payment is subject to survival, and thus this is why Q will not be taken into consideration. If the policyholder survives up until X+1, the first payment will be made. This is denoted by 1px on the timeline. This means that the policyholder will survive from X to X+1. Here, 1px means that the policyholder aged X lives for another year, that is X+1. V, on the other hand, denotes actuarial discounting, which, by definition, is the present value of €1 to be paid 1 year from now. At X+2, we will have 2px, meaning that the policyholder will survive from X to X+2. Here, V is squared for the reason that this is the present value of the benefit to be paid from the year when the policy was purchased, which is 2 years from the inception of the policy. Moving on to X+3, we have 3px, meaning that the policyholder will survive from X to X+3, all 3 consecutive years. Here, V is skewed for the reason that this is the present value of the benefit to be paid from when the policy was purchased up until year 3. This goes on to infinity. As we can observe from the timeline, a geometric progression can be determined, with the first term, A, being PV, which can be seen in the timeline at X+1, and R is defined as the common ratio, which is equal to PV. This is due to the fact that to receive the payment at the end of each year, one must survive the previous years from the inception of the policy, P, times the actuarial value of the past years, V. Now we shall start working the proof out. Since we have a GP, we will use A all over 1 minus R, since the geometric progression, as said before, goes on to infinity and does not have a defined end term. By substitution, A is equal to PV and R is equal to PV. By definition, we also know that V is equal to E to the minus delta. P is equal to E to the minus mu. Therefore, by substitution, we will get this equation. Since we have E to the minus mu times E to the minus delta, and we have two terms which are E, we can add the powers. This is the end of the first derivation. If you find something which is unclear, you can leave a comment below, and we will get back to your queries, which will be answered, given